We will be learning the fundamental concepts of managing processes in Linux. This tutorial breaks down how to create processes, monitor them using PS, aux, and grep, and safely terminate them using signals like SIGTERM. Every action you take on a computer, from opening a web browser to running a simple script, relies on a fundamental operating system concept, the process. In this video, we will explore how the Linux operating system handles these tasks. We'll cover how processes are created, how to monitor them using the command line, and how to safely terminate them when they no longer respond. Let us begin with process creation. In Linux, every process is an instance of a running program, identified by a unique number called a process ID, or PID. Processes do not simply appear. They are born from existing processes. When you type a command into your terminal, the terminal shell acts as a parent process. It duplicates itself and loads the new program into memory, a mechanism known as forking and executing. For a practical example today, we will create a harmless background process using the sleep command. By typing sleep 500 ampersand, we instruct the system to pause for 500 seconds, and the ampersand tells Linux to run it in the background, freeing our terminal for further commands. Before we find our newly created process, if you find these structured tutorials helpful, please consider subscribing to the channel for more educational computer science content. Now, how do we know our process is running? We monitor it. The most comprehensive tool for this is PS, which stands for Process Status. By executing PS aux, we request a snapshot of every process running on the system, regardless of which user started it. Because this output can be overwhelming, we combine it with a filtering tool called grep. By typing PS space aux, followed by the vertical pipe character, and then grep sleep, we tell Linux to pass the massive list of processes into grep, which filters out everything except rows containing the word sleep. Here, we can clearly see our process and note its unique PID. Once we have identified a process by its PID, we have the ability to manage its life cycle, which includes ending it. To stop a process, we use the kill command. Despite its aggressive name, kill does not abruptly destroy a program. Instead, it sends a specific communication token known as a signal. By default, when you type kill followed by the process ID, the system sends a SIGTERM, or signal 15. This is a termination signal. It politely requests the process to save its current state, close open files, release memory, and shut down gracefully. It is the digital equivalent of asking a guest to leave. However, programs can sometimes encounter errors and freeze, becoming entirely unresponsive to a SIGTERM. In these rare academic scenarios, administrators must resort to a forcible shutdown using SIGKILL, or signal 9. By executing kill -9 followed by the PID, the operating system kernel immediately halts the process execution, bypassing the application entirely. While effective, this should be used as a last resort, as it can lead to data corruption. You now possess a foundational understanding of the Linux process lifecycle. You can create background tasks, monitor system activity utilizing PS and grep, and systematically manage terminations using appropriate signaling methods. Thanks for joining us on this cybersecurity journey. If you enjoyed this content, smash that like button, subscribe to the channel, and drop a comment below.